Discrete Probability Distributions. Example 4. So the probability now is equal to k divided by x, and x can take these values, 2 or 4 or 8. So the probability that x equals 2, which we can write like this, that's the discrete random variable in uppercase, equals, and the lowercase value represents one of these, 2 is equal to k, which is an unknown, over x. What's the value of x there? 2. And then I can do the probability that x equals 4, that's k over 4, and the probability that x is equal to 8, and that's k over 8. And then we can put them into the table, and this is our probability distribution table, but we still need to work out the value of k. But we know that the sample space for x are these values here, they're in the sample space, so the probabilities here will add up to 1. So we write down a simple equation, sum of the probabilities equals 1, and we solve to work out what k is equal to. And then we can use the value of k to work out the exact probabilities. So these are the probabilities, and we have the probability distribution table for x, and these add up to 1. Example 5. So this time our discrete random variable x can take one of these values. So we've got some odd numbers here, we've got some even numbers here, and the probabilities you get, kx and 2 times k times x, depend on what value of x you start with. So the probability that x equals 1, so there's 1, that means I have to use this little formula, and x is 1, so it's just k times 1, so that will be k. The probability x equals 2, well 2 is here, so I have to use this to calculate the probability, so it's 2 times k times x, which is 2, so 4k. Px equals 3, so back here, so k times 3, or 3k, and px equals 4, so from here 2 times k times 4, so 8k. We can put the x values and the probabilities into a probability distribution table like this, and we know that the probabilities here will add up to 1. So if we add up all of these k terms here, we've got 16 lots of k equals 1, so k is equal to 1/16. So this is the probability distribution for the discrete random variable x, and you can verify that these probabilities all add up to 1. Now this definition for the probability distribution of the discrete random variable x takes into account these values of x. What about x equals 5 and x equals 6 and other values that x could take? Now we can cater for those by adding on something to our definition for the probability distribution, and that's to say that if x takes any other value other than the one specified here, hence the word otherwise, the probability for those values is 0. So if you see a definition like this and it's got 0 otherwise or 0 elsewhere, that's quite often it's written as elsewhere instead of otherwise, then what you're looking at is a probability distribution definition, which is like this. For practice, try these questions.